Hey, today we're talking about derivatives of inverse functions, specifically trig functions. And it's a little bit of a shorter section, so that'll be a nice little break from the chain rule. These can be found on page 304. It's theorem 3.13. These formulas you can put on a note card or something, use them as a reference. I don't expect you to memorize these. But what I do want you to know about how formulas are going to be written from here on out is that every time we use x, what that means is it's a possible chain rule. So it's not always just x. If there's more stuff in here, then you also multiply by the derivative of the stuff. Okay, so this is technically a chain rule, it's just that the derivative of that inside function is 1. Okay, so it doesn't change the value. So let's go through that formally so you can see that. If I have y equals cosine inverse x, and I want to know the derivative of that, I would say, okay, dy dx equals, now it's the derivative, it's a chain rule, it's always a chain rule. The outside function is the inverse cosine, and the inside function is the x. So if I was to write it out in all its glory, I'd be saying, okay, derivative of the outside function. The derivative of the inverse cosine is this formula right here. -1 over the square root of 1 minus space squared. Okay, that's the derivative of the outside function. Now I'm going to evaluate it at the inside function. So that's the green part, which is x, and I'm going to multiply it by the derivative of the inside function. And the derivative of x is 1. So my answer is just the formula, okay? So I want to really emphasize that we are still doing the chain rule. Everything is a chain rule. Everything is a chain rule. The derivative of x is a chain rule, okay? It's just that there's a whole lot of ones in the process. Okay, now let's take a look at what's the derivative. Let's say the derivative of cosine inverse of 3x minus 1. Okay. Well, this is, so chain rule again. The outside function is your cosine inverse. Your inside function is the 3x minus 1. And so I'm going to say the derivative is the derivative of the outside function. All right, that's going to be my formula. Cosine inverse right here is -1 over the square root of 1 minus blank hole squared. Okay, these x's are the blank holes that you're filling in. That's the derivative of the outside function evaluated at the inside function times the derivative of the inside function. So what that boils down to the derivative of this is 3. So that goes up onto the numerator, and I get -3 over 1 minus 3x minus 1 squared. And that's my derivative. Okay. Let's try another one. Okay. So when I look at this, I don't actually see a chain rule on face value. What I'm seeing is a product rule. I've got two things multiplied. So the product rule is the first rule that I'm going to lay out. Now there might be a chain rule later, But right now, all I see is the product rule, okay? So I'm going the derivative of the first term times the second term plus the derivative of the first term times the second term. Now I'm going to go carefully through my derivatives. First, this one. Derivative of 5x cubed is 15x squared times 1, technically, because it's a chain rule, okay, but we don't need to write that, times tangent inverse of x. Now, what's the derivative of this? This is a chain rule. The tangent inverse is the outside function, the x is the inside function. So tangent inverse, our formula for that is 1 over 1 plus the stuff squared. Okay, so that's the derivative of my outside function evaluated at my inside function, which is just x, times the derivative of the inside function, which is 1, because the derivative of x is 1. Okay, so it is formally a chain rule, but everything is 1, so it just ends up being the formula itself, times 5x cubed. All right, and that's it. I probably wouldn't clean it up at all. I like to put these on the top, but that's just a personal preference, and this is your answer. Okay, so you can go and try example 3.66. Okay, pause the video, go try that. We'll do one more. Okay, last example. All right. So if you remember from previous problems, anytime we see a root, we like to write that as a power. It makes the calculus part easier. So this is the 1/2 power. Okay, and what I'm looking at is a chain rule. So my outside function is the power rule. My inside function is this cosecant. All right, so f prime of x is the derivative of the outside function, okay, that's my power rule, evaluated at the inside function, times the derivative of the inside function. All right, now let's take a look at this. This is also a chain rule. The outside function is the inverse cosecant, and the inside function is 2x. So that derivative, this 1/2 stuff comes along for the ride. Just recopy it down. Okay, derivative of the outside function. Okay, cosecant inverse. I go up to my table of formulas, and cosecant is this big mess. And it's got 2 places to plug in my inside function. So it's -1 over the absolute value of the stuff, okay, times the square root of the stuff squared minus 1. So everywhere I see x in that formula, I'm leaving a space. That's the idea. So that's the derivative of the outside function, evaluated at the inside function, which means plug 2x in everywhere you have the space. Okay, times the derivative of the inside function. And that derivative is just 2. Now I'm writing out this step. I would, if you see that the 2 and the 1/2 cancel, do that right away. That will speed you up, but I just want to lose as few people as possible along the way. Okay, the derivative of this is 2. And since this is all multiplied, you can combine in any order, and I just see these guys, okay, they cancel. And if you want to, you can throw this thing on the denominator because it's a negative power. If you don't, that's okay. But what that looks like is -1 over this absolute value of 2x squared minus 1, and then this is on the bottom now, and it's a root, because that's what a half is a root on the bottom. -1/2 is a root on the bottom. So this would be your derivative. Okay, so that's about it. It's kind of, the idea is follow the formulas, and then just everywhere you see an x is the stuff if it's a chain rule, and you just plug that in there and then multiply by the derivative of the inside function. All right, try some problems.